I've seen Nesta more in the last 2 weeks.
Did you hear that, Nesta?
No, I only got a part of it.
Melissa said she's seen you more in the last 2 weeks than I did.
Yep, that is correct.
It's been 2 good weeks.
Yeah, exactly. I
Yep.
was on 2 PhD committees, and so the last one was, we had so many good questions, like interest, that we decided as a progress to go another round. But it was good. It wasn't like, it was because we were all really interested.
Well, should we go ahead and get started? Okay, well, we're going to go ahead and get started. So welcome, everyone. We appreciate you joining us this morning. This is our second part in a series of speaker sessions between the University of Pittsburgh and the University of Lagos. And we're so excited today to have expanded that even further and have a speaker from the University of Johannesburg joining us. We are really excited to connect, as we both have, and I guess today all three have common interests in spaces that really promote thriving communities and that think about sustainability and how we can really grow together in the face of regional and I guess now we can say national and international changes. Our first session gave us a great look at circularity work here in Pittsburgh as well as in Lagos. We heard from Dr. Melissa Billick on a circularity assessment protocol tool that's being used here and abroad. And we heard from Dr. Inyavong John around a lot of the policy work and really amazing progress and goals that the state of Lagos has set to reach circularity goals. And today we're going to hear about digital twin technology, a space that's very new for me, so I'm excited to learn in that space. And in the spring, we'll continue with at least one more, hopefully 2 more speaker sessions, but we'll have topics that include crime prevention through environmental design, joint research work that folks here at the University of Pittsburgh, as well as folks at the University of Lagos are working on. So we're really excited to share that with you as well. For today, though, I'm going to turn things over to Dr. Vikas Kahana, who's a professor and interim chair of civil and environmental engineering at the University of Pittsburgh. Dr. Kahana earned his BS from Punjab University and his master's and PhD from the Ohio State University. I have to say it that way. His research expertise lies in sustainability science and engineering with a focus on modeling and assessing the impacts of emerging environmental and chemical technologies. He is recognized for real-world relevance with his research and has been featured in prominent media outlets, including NSF Research News and Inside Climate News. So Dr. Vikas, I'm going to turn it over to you.
Thank you so much, Tina, for the kind introduction and for all the work you've done to bring our speakers together and this conversation together. So good morning, good afternoon, and good evening to all the audiences and participants joining us from Johannesburg, Lagos, Pittsburgh, and those beyond. We are excited to welcome you to today's Digital Twin Innovation Panel, where the focus will be to explore how digital twin technologies are shaping the future of infrastructure, sustainability, and smart cities across very different urban contexts. So with that, we have an exceptionally distinguished panel today with us, representing 3 global cities and diverse perspectives across engineering, construction, sustainability, and digital transformation. And with that, it is my great pleasure to introduce our speakers. First, we have Professor Clinton Ibaboa, who's a leading voice in construction management and sustainability at the University of Johannesburg. He heads several research initiatives focused on building smarter, greener, and more efficient projects, and directs the construction industry development board's Center of Excellence at the University of Johannesburg with over 1,600 publications, super impressive, and dozens of books. His work explores how technology and innovation can transform the construction industry, especially in the global south. Professor Clinton has mentored hundreds of graduate students and regularly shares his insights at conferences around the world. So please join me in welcoming Professor Clinton. Next, we have Professor Inyobong John, who is an accomplished scholar in construction economics and project management with a strong focus on sustainable development and digital transformation. She serves as a senior lecturer at the University of Lagos and a senior research associate at the University of Johannesburg. Professor Inyobong has authored over 50 peer-reviewed publications and has supervised numerous postgraduate students. Her research spans procurement systems, competitiveness, and circular economy, supported by prestigious grants from the World Bank, AFRETC, and the European Union. She also contributes extensively to advancing strategic project management and urban infrastructure development across Africa. So please join me in welcoming Professor John. And lastly, last but not the least, is our very own Dr. Melissa Billick. Dr. Billick holds the George M. and Eva M. Ferrier Endowed Chair in Civil and Environmental Engineering within the Swanson School of Engineering at the University of Pittsburgh. And she also co-directs the Mascaro Center for Sustainable Innovation, which is truly the hub of sustainability here at the University of Pittsburgh. Her research focuses on life cycle assessment, building energy modeling, and circular economy to advance sustainability in the built environment. She has published over 100 peer-reviewed journal articles, secured over $20 million in funding, and her research team is exploring how to advance digitalization and sustainability in the built environment. So please join me in welcoming Dr. Billick. So with that, we'll now move into brief introductory presentations from our three speakers, where they will frame their work situated within their city and share their insights on how they're using digital twin technologies and practice. So we'll start with Professor Clinton Ivanova first, and I'll make sure that Professor Clinton has.
All right. Am I audible? Hello?
Yes, you are.
Okay,
Yeah,
thank
we
you.
can hear you.
All right, thanks.
We can hear you, but we don't see you.
I'm just hiding here.
You're
I'm
hiding.
sorry. I'm actually in a resort and it's kind of really far away from Joburg. I think the connectivity is a little bit very poor. Yeah, thanks.
No problem.
Okay.
We do see your photo there. So.
All right, thank you. Thank you very much, everyone. I'm very excited to be part of this panel for today and also to contribute to an ongoing work that you guys are already doing. I'm not really new to the University of Pittsburgh. I've had the opportunity of hosting them twice in Johannesburg for, I think, for student exchange. So what I want to speak about briefly is on digital twin technology paradigm for smart management in the built environment. I'm actually going to present findings of a research that we did sometimes last year. It's actually an ongoing project. It was part of a broader study, which is actually funded by the National Research Foundation in South Africa here. I just want to appreciate everyone, not in any particular order, but thank you very much for involving me and also to Professor John. Okay, I'm from University of Johannesburg. This is how our campuses looks like. We have 4 campuses. I'm actually at the Bunty Road campus at the moment, where my research center is actually situated. Okay, I'm not going to bother you with this. We're doing quite a number of work in terms of trying to contribute to the body of knowledge. I think one of the things I want to bring out here, when I look at the topic and also to think about some of the things I want to speak to shortly to say why digital twin and why smart management in the built environment. I think one of the first things I want to say is that we will in the global south will actually be confronted with infrastructure deficit, and also there is the aspect of environmental imperatives of the 21st century. And you realize that there are tools which I believe that we should deploy that can actually enable us to surmount some of these challenges. And today, I'm going to look at something we're looking at within digital twin, but relating into indoor environmental quality. I think that also speaks to the School of Health and all that. I'm not really going to spend a whole lot of time talking about this in terms of the current digital paradigm, considering that digitalization has really advanced significantly beyond what was actually envisaged since 2020. And also recently, their development in new generation technologies that actually are trying to really accelerate progress for smart infrastructure management and much more relating to how to better manage the environmental qualities within a space. I think there are innovations like the three-dimensional systems and also looking at artificial intelligence and cloud computing. But relating to what I'm looking at is more or less a fusion of IoT with artificial intelligence, creating a cyber physical systems to actually be able to manage the indoor environmental quality in a particular space. I'm not going to really bother about this too much, but looking at the current revolution, which is bringing about newfound interlinkages between the real world and the physical world. I think one of the things that we must basically pay attention to when it comes to the fourth industrial revolution is that it is kind of really helping the global south to leapfrog and also to be able to manage its built environment. I think digitalization kind of really underpins a whole lot of global innovations and trying to really help us to drive new methods of designs, operation, and much more the aspect of problem solving across every industry. I think, and the whole concept of digital twin has really emerged as a powerful tool, which is really providing a virtual representation of physical systems for enhanced monitoring, also helping us to analyze and also to optimize the space that we're actually working in. As we all know, the digital twin is more or less a digital replica or a representation of a physical system, an asset, and to kind of really enable uh, systems or to manage or to monitor and to analyze and also to optimize systems either remotely or to test scenarios and also to predict future performance is one of the things that we actually thought about when we were conceptualizing the experiment, which is what I'm going to present to us very shortly. Okay, then I think the whole concept of digital twin is one that kind of really ensures that I see digital twin as a very dynamic digital representation of a physical object. And considering some of the things we are doing at the moment within my research center is actually creating digital replicas of bridges because we've had issues with failed bridges and we're trying to work with the local municipality here to actually enable carrying out the condition maintenance and also to kind of really carry out real-time predictive assessments of infrastructure. But we're looking at water dams, we're looking at reservoirs and also bridges across Johannesburg. It's one of the things we're working on for the new year. And looking at the whole aspect of the digital twin for the built environment, I think one of the things we need to look at here is that the DT kind of really functions by continually drawing data from a particular physical system, and that is through the creation of an accurate virtual counterpart. If that is not there, we will not be able to kind of really monitor or to harness the data from those particular systems. So I think the whole model of DT depends on the real-time information about either you're looking at the conditions, the boundaries, even the behavior, and also looking at some specific parameters which must be in place, and also looking at the system dynamics that will enable us to create a very precise and responsive digital representation of that particular object. And in terms of our research motivation, one of the things I had in mind was looking at the whole emergence of BIM. You know, the application of digital twin technology within the built environment is kind of really something that is still new within the global south and mostly in South Africa. But from experience and looking at work from other geographical contents, you realize that apart from providing a virtual duplication of the physical asset, we also have the opportunity of creating that particular opportunity for accuracy and usefulness to measure accuracy of how this object actually, or this infrastructure actually performs. So I think one of the things we had in mind was to basically model the intelligence of a particular space to see how it performs and how it actually is functioning. And in terms of the digital twin for IEQ, that's indoor environmental quality. For indoor environmental quality, this for me represents a very valuable approach, bringing DT into it to enable us to optimize and at the same time to enhance the health, the comfort, and the well-being of the occupants in the built space, because we know that we spend more time indoors compared to outdoor. So IEQ kind of really encompasses various factors like the indoor air quality, the temperature, the humidity. Also look at the lighting and also the acoustic properties. And we believe that by creating that particular dynamic digital replica of the space, that DT will help us to simulate, also to analyze and to monitor the performance of the various systems such as heating, for instance, ventilation, and even the HVAC and the acoustic properties of that particular space. That was basically some of the things that we had in mind in terms of actually infusing DT to measure IEQ. So the research kind of really began with an extensive literature review where we tried to establish the theoretical foundation and then we identify existing gaps. So, and building on this, but building on the insight from the literature, we then created a prototype system that was developed to kind of really demonstrate the feasibility of the application of DT concepts to indoor environmental quality. So the prototype was subsequently tested through field experiment. I'm going to show us something quickly, and which kind of really allow us to kind of really measure to gather real world data, which was collected, and then to also test the system performance. There we're able to evaluate kind of actual operating condition of that particular space, and results from this field experiments will kind of really inform the final phase of the system refinement, which we are still working on. We're actually trying to scale it to lecture halls within the campus. The process was such that we had 4 phases. I think the first phase involved the initiation phase, where the project scope, functional requirement, and also performance expectations were clearly defined. Then in phase 2, we created the virtual twin, and also we integrated this with the relevant data streams that will enable us to kind of accurately measure the digital representation. Then we had the phase 3. Here we're focused on the enrichment and also the utilization, and also enabling the continuous communication between the physical and the virtual environments. And this kind of really help us to manage the real-time monitoring and analysis. Then the last phase was to kind of really address a reuse in terms of ensuring effective information management, so that insight that were generated by the digital twin could actually support an ongoing decision making, and also looking at how can we use it to optimize the system, and also looking at a long-term asset performance. And in terms of the parameters that were measured, we kind of look at various parameters like the temperature, lighting, and all that, and we ensure that the parameters were kind of really related to the World Health Organization standards for IEQ qualities. And these parameters included things like we measure the temperature, relative humidity. We also look at the air speed within the space, and also the light levels of which influences the thermal and the virtual comfort of that particular space. And in addition, we also try to measure critical air quality indicators like the carbon monoxide, for instance, the CO2. Also, we looked at the particulate matter like PM 2.5 and PM 10, because we believe that they do have a direct implication for occupant health and also well-being. So the continuous monitoring of these particular variables enable the digital twin to then provide an accurate real-time assessment of the indoor conditions, thereby supporting an early detection of things like risk, and also guiding interventions to maintain a safe comfortable space. That was some of the things that we tried to look at. In terms of the digital twin monitoring system, we had the internet-based sensors which were installed within the indoor environment to continually capture the key environmental parameters which we had actually set, and also to transmitting this data through a cloud-based platform. Just to mention that the privacy of the users of the spaces were not infringed upon, because the sensors, basically there were no cameras, and it was not also recording the discussions within a particular space. We kind of really ensure that the sensors that we use have this particular privacy in terms of the aspect of knowing what kind of data is being collected. We explain to the occupants using this particular space in terms of what we're collecting. So the system developed kind of leverage on, we use the Microsoft Power BI and also Unreal Engine to then render the data in three-dimensional visualization, which then enable in a near real-time interpretation of the building condition. So here's some of the things that we kind of really carried out when we're carrying out the experiment. In terms of the results, like one of the things that we're trying to create a bidirectional coordination in the context of digital twin, which kind of really relates to a continuous two-way exchange of information between the digital twin and the physical counterpart. So we created a digital replica and simulated in terms of how the arrangement of the space and also the movement of the occupants, which were recorded within this particular space. So the real-time environment data were captured, things like temperature, humidity, airspeed, carbon monoxide level, particulate matters. All these were integrated directly into the virtual environment, which enabled that dynamic monitoring of the indoor environmental quality. It kind of looks like something like this. I just want to show us a little video. It's not so long, just to show the space in terms of how the system performed in real time. This was basically the space, and we had like a virtual object. And in real time, if you look at the left-hand side, within like in a particular day, you could actually see the temperature rise within the space, the humidity, the airspeed, the carbon monoxide level, carbon dioxide, PM2, PM10, and even the illumination in terms of what is happening within the space. Even when the windows are open, we try to get some actuators in terms of controlling the windows. That was a little bit complex for us. We kind of really relied on the occupants of the space in terms of when they open the windows and also when they close the windows. I think that was one of the things that we did in terms of the experiment. I'm just going to move from this. So in terms of the result, I think one of the things I want to bring out is that we kind of found that when we analyze the real-time and historical data which was collected, that the digital twin kind of identifies correlations and also predict the optimum moment for adjustment in the building conditions. For instance, there were aspects in terms of how do we regulate the artificial lighting, how do we, adjusting of the blind or opening or closing of the windows, and also modification of the air condition in the space. The system kind of integrated big data analytics with benchmarking standards to inform optimized management practices. So this kind of really created a smart management plan that continuously responds to the user's needs and environmental changes. I think one of the things that we observe is that it's at a certain time of the day, the occupants, some of them feel very uncomfortable when the carbon monoxide level is a little bit high within the space. And kind of really, we collected data over time. And at the end of the day, the model kind of really ensures a complete interaction among the process, the people, the place, and also the device, and also the device that was used. And in terms of the futuristic application of our results, we kind of believe that beyond this particular space where we have applied it, that it can also be used to simulate large lecture halls, which we are trying to actually do at the moment in the new academic year. We're looking at some lecture halls. We're also trying to create a smart campus to look at creating our campus air quality index. We actually have the equipment already, which we're actually looking at. I think it's also useful to actually create a city-wide digital twin, which can also help planners to optimize city planning. I read something about Estonia the other day. I think Estonia is big in digital twin. They're actually creating a digital twin of the entire Estonia, which is something that we can also look at to say, is it possible to create an entire digital twin of a campus? So I think in conclusion, the digital revolution is really transforming every aspect of our lives, and we believe that it's going to come with a whole lot of importance, actually making us to understand how our species behave better. As I said, this is an ongoing project. We're trying to actually scale it, and within the global implications, the study actually relates to the SDG 9, SDG 3, which is critical, which was a critical focal point for the study, the good health and well-being, and also looking at the aspect of sustainable cities and community. One of the things that we are doing at the moment, in terms of our response, we are trying to create a digital lab to actually kind of really, should I say, scale what we have started already. We've actually taken delivery of some equipment to actually carry out a better modeling for our space by creating a digital twin for our campus and also for the major lecture halls within the university. Yeah, I think I'll stop here. Thank you very much.
Thank you, Professor Prince. That was very insightful and great. So now we'll move on to Professor Inyabang John.
All right, thank you. So I'll be looking at digital twin from what we're doing currently at the Center for Housing and Sustainable Development, University of Lagos. Okay.
Dr. John, can you hear us?
Yes, can you hear me, Prof?
Yes. Are you able to share screen?
Yes, can you see my screen?
Not yet.
Okay. Let me try to share it again. The network here is really poor, but I'll see.
Thank you. It looks like it's starting now.
Okay.
Yes.
Can you see my screen now?
Yes, we see it now.
Okay, so I'm going to just discuss briefly about two projects that we have done. They are both ongoing on digital twin in the built environment. The first is on digital twin and the project management, where we'll try to create a digital representation of an ongoing project site in order to provide real-time data on the work progress. And so we started that research a couple of months ago. And where we are at right now is that we needed to model every member, every object on that project. That implied that we had to do real-time heavy modeling of the different components of the construction project so that the sensor can read in between the work progress at a particular time. And we also needed to train the model to identify incremental changes in the work progress so that going forward in managing projects, there can be real-time updates on projects, on the progress of work. And as we know, digital twin is dynamic and virtual representation of a physical system or process or object. And this is usually updated in real time. So one of the issues where we are at on that project presently is modeling every bit of the members so that the model can be trained to identify work. So we looked at digital twin as it integrates sensors, historical records, and simulates data to reflect the current behavior of its physical twin. So for scaling that project currently would require the completion of that developing of all the models. We started with modeling with the block work on that construction project. I don't have the pictures here. And that model is ready, and then trying to therefore move that to real time for the twin to be able to provide work progress on scaling up on the block, on the progress on site. Basically, we're looking at a bi-directional data exchange and real-time flow of information between the physical and the digital entity, and also needing high-fidelity simulations, life cycle integration, and decision support. The second project is with one of our PhD students at the Center for Housing. Is focused on developing a digital twin for the air quality of Lagos. We have sensors that monitor the quality of the air all across Lagos from other projects, and the university has that. We have that data within the university. However, we do not have a digital twin monitor that tells us how the outdoor air quality is outside Lagos. Lagos is known for its high carbon emission, but however, the government is working assiduously to ensure that we have a lot of reduction, working towards them scaling down or reducing or working towards the net zero emission. So where we are on that project, we are using bioelements of certain plants that are able to purify the air, and working with certain genetic modifications on those outdoor plants that can help to reduce, and then seeing how real time the implication of having having those plants in certain controlled locations where we have the equipment for the outdoor air quality reducing, then we then model the physical, we now use the digital twin model to reflect how the controlled variable areas are, and then in the hope that in the near future we'll be able to scale this up and make Lagos a net zero city. Now, do we have challenges in Nigeria regarding digital twin? Yes, we do. And majorly, it's really the challenge of having sufficient, the reality of standardized models. Now, for the project in the built environment, the challenge of having standardized models has been a major one for us. And then the issue of communication between the physical and virtual world, the internet access is available. However, it needs to be improved to be able to provide real-time data in a seamless manner. So this level of efficiency is what we do not have currently operational, and it's hampering research in that area. We also looked at basically how the core values of using the digital twins can continuously synchronize and help with life cycle integration across the built environment and across the other research we're working on outdoor air quality. So basically, we have some of the models already, but I haven't been able to share them here now. But these are the things we have done in project management, digital twin models for real-time project management in the built environment, and digital twin on outdoor air quality in Lagos to help the drive towards the Net Zero Lagos project. So those are the things both are underway currently, and in the near future, I'll be able to present more findings on that. Thank you.
Thank you, Professor John. Now we'll move on to Dr. Berek.
Okay, can everyone, let me just make sure my slides are okay. Can the people on Zoom hear me okay? Oh, hold on, please. Oh, we're good. Oh my gosh, it worked. Okay, Gina and Mary, it worked. So good, they worked so hard at that. Thank you both. So I'm so thrilled to be here today, and I wanted to thank Tina for organizing it, and Dr. Khanna for being our moderator. And today's actually a really special day because the PhD student who's done a lot of work in this space is defending today this afternoon. So I'll make sure to recognize her, but we're really excited for this day in general. But I get to co-chair the Mascaro Center with my colleague Gina here, and I'm a professor in civil and environmental engineering. And one of the things that I always think about is like, how can we make systemic sustainability progress in the building sector? And so what I mean by that is like, how could we pull like one part of maybe a spider web to really have catalytic change over time? And, you know, that we think there may be an opportunity to move in that space with the concept of digital twin technologies. And so one of the reasons why I work in this space, and I feel really honored to work in this space, and I say this all the time, is civil and environmental engineers contribute probably more than any profession to our climate change issues. And so this is a slide. I love the slides by Architecture 2030. I really like this one. This is the one that shows that in the US, the built environment is responsible for about 42% of the greenhouse gases. And so that's things from running our buildings, but also related to things like the materials as well. But the great news is that as civil and environmental engineers and collectively, we have the opportunity to be a part of the change, a really significant change that I hold near and dear to my heart. So unlike our previous two speakers, we're from the US and we're from the city of Pittsburgh. And one of the things that Dr. Ndo and Dr. Khanna asked us to do was to say a little bit about where we're from. So since we're so international. So Pittsburgh is located in the state or the Commonwealth of Pennsylvania. And the population of Pittsburgh in and of itself is about 300,000. But in Allegheny County, the population, which is the broader kind of jurisdiction, if you will, is about 1 million. So much smaller than our colleagues that we have the opportunity to talk with. And one of the really cool things about Pittsburgh, though, is that we have a strong commitment to energy reduction and carbon reductions in 2 different mechanisms. There's more, but I'll talk about them today. The one on the bottom right is something called the Pittsburgh 2030 District. And the 2030 districts, there are several around the country, but they have voluntarily committed to reducing energy and other metrics as well to meet goals by 2030. And then they're looking at it beyond. So this is an example of the Pittsburgh 2030 district. You'll see that it goes up into the Oakland neighborhood where we are currently located. And there's over 540 buildings committed within this boundary and about 86 million square feet. And from memory, and Aurora would know better than I, it's about 90% of the central business district. It's a really high number. So like everyone's all in. And then the important thing is it's voluntary. It's voluntary. At the University of Pittsburgh, we've also made the commitment to be carbon neutral by the year 2037. And so you see this little question mark right here, like, how are we going to get there? if we know that buildings are at 42%, nationally, we need a plan related to buildings, because if not, we're not going to get there. And so that's really what a big part of my research is. And I really want to echo what Prof. Clinton and Prof. John said. And one of the things is there's so much disparate information. There are different standards, there's inconsistencies, and it's really hard to do that when you're essentially doing this really big data science exercise of bringing all these data streams together. And so, that's really what we've been trying to explore. I also worked at our local urban redevelopment authority in Pittsburgh for 7 years. And I always am thinking, like, how can we help the city? Like, what can we do? And so years ago, with one of the PhD students that I worked with, Rezvan, I said, I would love to put together all these different layers of how is the material flowing? How is the energy flowing? How does that relate to carbon? And inform the different regional decision makers on how to make these decisions collectively. And so we started to do that, so we did things like put together this really different kind of layers of a map. And I'll walk through that and show you how that kind of has evolved over time. But again, I really want to go back to, a goal without a plan is just a wish. And so to say that we're going to meet these goals is we need a plan. Like, as an engineer, I'm like, we need a plan. And so these are 2 ongoing projects that we've had. The first one I'll talk about a little bit more briefly, but it's really informed the work that we're doing with digital twins today. So again, this was the work that was done by Rezvan and our research team. And we answered questions like, what materials are in place in the buildings? When will the new material be needed? So when will we demolish buildings, and things like, how much energy is used in the buildings? And how will that change related to climate? And how do we need to think about this holistically? And so this was before the concept of digital twins even came into my radar screen. And again, this is Federica, who's working on her dissertation today. And this is Rezvan, who's doing large scale energy analysis across the US. So she's utilizing her work from her PhD, which is great, thank goodness. So what we did is we developed this urban building energy modeling and material stock and flow analysis for the government and educational buildings in the city of Pittsburgh. And we went through this really long process. Step 1 was the GIS footprint. And I'll say Dr. Clinton, Prof. Clinton went through something similar. We developed things like the envelope properties. We used LiDAR analysis, Energy Plus. We used all these things to come up with this work. And this is an example. And at the end, what we were able to do was to do a prediction of the energy use intensity of the different buildings. And so this is an example of one of the figures from our paper. And then what we also did was look at the amount of materials in the building by the amount of materials. And we're continuing that work now with the PhD student Rahaf to further disaggregate and look at that work at a more granular scale. But what we realized quickly is this was really hard work, people. This was hard work. And I mean, Rezvan is a very hard worker, and it is so much hard work. So at the same time, we're like, wait a second, what's this digital twin thing that we know about? Can this help us? How, this might be much, much better. So we started to combine aspects of the work that we were doing in the digital twin technologies. The first thing that we did was, it's a review paper, but it's kind of much more of a review paper, look for opportunities to use digital twins in what we call urban metabolism. And we really started to try to understand, what is a digital twin? How can we utilize it? And I wanted to echo what Prof. Clinton said. I also agree that indoor environmental quality, especially in the built environment, is a key way to integrate the work that we're doing within a digital twin technology, within digital twins. Also, and I think energy and material flows are also 2 really important elements as well. So what we worked on was this kind of flow of information. So the first thing that we did was we're working through creating the digital twin. And I'm gonna focus on these ones today. We're also we've integrated elements of dynamic modeling as well. And I also have colleagues that are working on climate adaptive building technology. So that's Dr. John Brigham. And then Dr. Alessandra Fischetti is working on also aspects of digital twin technologies too. So, I'm sorry, this should say under review. So this is our process. And so what you'll see right here is what we did, and this was also what was done by Dr. Clinton, is and this is for an existing building. This is actually the building that we're in right now. It's the Mascaro Center for Sustainable Innovation. So we had a lot of the construction, we had all the construction drawings. We also did a really in-depth laser scan of the building to see like, what data is better? How can we actually utilize that? And then what we did is we created a building information model. After we created the building information model, we did two kind of sustainability assessments. One is looking at the material flow analysis. So what material is in the building and when do we predict it will either need to be replaced and it can be used for other purposes. And then we also did a life cycle assessment to estimate the carbon dioxide emissions. We also tried to integrate something called the building automation system, which in our case allows us to look at things like the temperature and aspects of air quality as well. And then we put all of this information into the digital twin. And so that's kind of where that's at. So let me walk through this a little bit more. So this is the digital modeling that we did. This is step one. And this is where we're at in the research. I'll say like, we're at the like how to make the recipes. You know, like that's really where we're at. Like, this is what I say, like, what is the recipe? Like, how do we actually do this work? And we're integrating like engineering, architecture, data science, and climate modeling in a really unique way. So I'm excited about it. So we did the quantity takeoff. And then what we did is we utilized Dynamo to actually go in and extract the bill of materials from the building information model. And the Dynamo script that we used was developed by a really great researcher. His name's Stefan Pollack. And then what we did is we were able to think about how we can take the current information and do the energy analysis. So we can also do the energy analysis as well. So within the tool that we use called Revit, is we created the different zones to calculate the total amount of energy used on an annual basis for our Mascaro Center. I will say one of the key learnings that we learned is that our level of detail that we created for the building information model was actually too detailed for Energy Plus. And we were getting so many errors that we had to go down in scale for the energy analysis. But we needed the level of detail for the material flow analysis. So it was a really important lesson for us to go through. The other part that we did was the material flow analysis. So what we really tried to show was how much material is in this building, right? And then what is the building stock? And when will that change over time? And so we went through that analysis, and just on the bottom kind of shows a visual of what something would potentially look like. I'll show that later as well. So the last part that we did, and this is probably what people maybe are most thinking of when they think of a digital twin, is and this is so it is an Unreal Engine, and that's also what Prof. Clinton used. Is we were to take the visualizations that we created from the building information model and start to then think about what visualizations do people want to show or do people want to see, so that we can so people like Evan and Aurora can make good decisions in the buildings that then they are ultimately helping us to support at the University of Pittsburgh. And this is a non-trivial matter. It takes a really long time to create all of this information. Okay, hold on. So one of the key parts that we did related specifically to the digital twin technologies is try to figure out how to integrate the building automation system. And so when you think about a digital twin, which is different from a digital shadow, is that you have a two-way street of information. And it was really difficult to do that. And what I'm seeing currently in the literature is people just using the word the inoperability of being able to do that. So if you aren't familiar with the building automation system, what you'll see here on the, I think you can see my my cursor, is on the upper right. This is an example of what a visualization in the building automation system would have. So this particular one is for air humidity. And so you can see in room 102, the air humidity would be good. Or in room, you know, like what some of these rooms, you can start to see where the humidity would be good versus not good. So what we tried to do was to take the information from the building automation system and understand how we could predict that over time using Energy Plus, which also includes a relative humidity calculation. And so we're starting to see like the actual versus predicted. We see, I mean, I think relatively good points over time. And then you're also seeing the heat map, which shows where Energy Plus ultimately overestimates or underestimated systems. So we're starting to get at like this kind of two-way system and also looking at predictions, which I think is a really important part of the digital twin model. And so this is also like our ultimate, like an example of what we would really like to do moving forward. So this is on the second floor of the Mascaro Center. And what we hope to do is to have people be able to like click on these different elements and see things like, okay, what time of the day is it? This is an example of temperature. And then also to see things like, where is this located all in one total screen? And so, you know, there was a lot of work done just to kind of to get to that point. And then the other element that we hope to do is to bring in kind of the research that I've been doing for a number of years related to the life cycle assessment, and then also to the material flow analysis. And so you can imagine if you were, you know, walking around the street, and if you're like super geek like I am, you wouldn't know the amount of materials in this building. So you click on this button and you see like, oh my gosh, the greenhouse gas emissions are 240 kilograms of CO2. You can look at the things like how much material is actually in this building, and when is the gypsum going to be gone? Like, when do we need to replace it? And then if there are other people that are also super interested in that, then you could also imagine gamifying it, which would be so much fun. And so again, part of it is really inspired by bringing everything into one framework and like doing this from a sustainability lens. And hold on one second. Try to advance it. This is just one building, right? Like, how do we scale this up? How can we do this more building? And if you're interested, I'll do a shout out. So Federica has taken the one building and now she's expanded it to 7 additional buildings on O'Hara Street. And so she'll be talking about that in her dissertation this afternoon. And so that's, again, we're working towards that. And we're really trying to make us move into a plan. And these are all the super talented students that I've been able to work with. And every single one of them is just wonderful. So thank you.
Thank you, Melissa. That was great. And having served on all of these two committees, I can you know, attest that it's been years of data collection, modeling, and so a lot of work that goes behind the scene, which is hard to capture, you know, within 15-minute talk. So thank you so much. And again, I also want to thank all of our speakers for their insightful presentations. So what we'll do now is we'll move into a moderated Q&A with the discussion with the panelists, and I have some questions to guide our discussion. And after that, we'll open the floor for questions from the audiences here who are in person as well as those who are joining us virtually. So I'll start with the first question here. So the question is that a lot of digital twin projects, they start as pilots, and so what barriers exist to scaling digital twins or digital twin models across infrastructure systems? I know Melissa talked about, scaling from, for example, one building to say multiple buildings on campus, right? So if we talk about like other infrastructures like energy, transportation, waste buildings, and what strategies have you found effective or have recommendations for to move from concept to citywide or even larger scales?
Prof. Clinton or Prof. John, would you like to go first?
Okay, I think let me go first. I think thank you very much. I think I enjoyed the presentations from the other two speakers. I think on my side, in terms of the value that digital twin actually serve across infrastructure project, yeah, most DT projects actually start as pilots, but there is a wave at the moment, an increasing awareness of the usefulness of digital twin, and that is actually making most countries or even establishments. If I use South Africa as an example, considering that we have a lot of aging infrastructure in South Africa, the Department of Road and Infrastructure, for instance, they kind of really have been exposed to what digital twin can do. So I think it's actually moving away from just starting as a pilot. So you realize that most digital twin pilot projects, because of the significant value that they can offer across various infrastructure systems, and based on what has been demonstrated in terms of the data simulation, in terms of the predictive analysis, you realize that they actually have the potential to transform asset performance and also for decision making. I think one of the area where we really find it kind of really is going to revolutionize built environment infrastructure is predictive maintenance, because you realize that digital twin is going to help us to kind of really carry out should I say, it's going to provide a low risk environment where we're actually able to kind of test the digital capabilities, but at the same time, even to optimize our operations. And also realize that it also enhances the visibility of the asset behavior, because with one of the projects we are currently conceptualizing for a PhD project for bridge condition maintenance, one of the things that we have scoped and what we see that it can do is actually enhance the visibility of the asset behavior. There was one of the bridges in Johannesburg in 2019 the bridge was actually just less than a kilometer that was actually closed for over 8 months, because suddenly, I think one morning they realized that a section of the bridge was actually collapsing. It took over 8 months for it to be repaired. So I think there's that particular dimension to know that it needs to move beyond just pilots, because it's going to enable early detection of faults, and at the same time it will also improve maintenance planning and also to reduce even the operational costs. So I believe that through the previous pilots and the scenarios, the modeling will actually enable assets to build resilience, like what we just heard in terms of the aspect of sustainability. So I think ultimately, digital twin pilots, they have helped to build institutional confidence, and also they also help us to reveal what I would call a measurable performance gains. And then we are actually able to now establish it has actually enabled us to establish a scalable foundation for more smarter and resilient infrastructure management system. Yeah, thank you.
Thank you, Professor Clinton. Professor John, would you like to add that?
Yeah, in the infrastructure sector in Nigeria, one of the core that the digital twin technologies poised at doing for us is to enable data-driven smart decisions. Right now, we have infrastructure deficits in Nigeria and major parts of developing countries. However, the existing infrastructure um, requires a lot of maintenance and predictive maintenance. However, rather than get to deplorable situations where full infrastructure collapses and whole cities are put on hold, like recently in Lagos Island, one of the major roads would be put on hold with heavy traffic for about 8 months for maintenance. But when we have digital twin models of all of this infrastructure, particularly in the city centers, would be able to have data-driven smart decisions. Now, these data-driven smart decisions cannot be taken where you do not have real-time information which the digital twin provides of the replica model. So basically, for us, one of the key gains would be the data-driven smart decisions within the infrastructure sector of the built environment in the global south. Thank you.
Thank you, Professor John and Alyssa. Would you like
Yeah.
to add to that?
Yeah, thank you. So, I think there's like a couple barriers. I think for me, one of the biggest barriers is the data quality of both horizontal and vertical infrastructure is really limited. And so, for example, some and actually many government agencies in the US are still utilizing like paper bidding. Do you know the quality of the data, I think, is just really difficult. And my sense is that, at least in the US, we are not going to have consistent data until the government agencies actually advance in their digitalization efforts and the project owner. So I think that that's kind of like one school of thought. And then the other thing that I think about is also like, is there the opportunity to kind of leapfrog building information models by creating digital twins? So building information models have been around for a number of years, and they have been met with, I would say, like modest acceptance in the construction industry. And so there's a number of reasons why. One might be related, there's always contractual issues, and it takes a long time to create building information models. But if we can actually leapfrog beyond building information models to more, whether it's like scanning methods or more things utilizing different available satellites, I think there may be the opportunity to really drive digital twins in the built environment in a way that building information models weren't able to do so.
Thank you, Melissa. That's very insightful. So the next question, I think, touches like, diverse audiences from students to faculty and practitioners. So the question is that what skills and partnerships are most essential to developing a workforce that's capable of building and maintaining digital twin ecosystems? So of course, you can develop, but then what do you do with it? Like, what skills do you need to make sure they're functioning, right? And connected to that, how should we train our students so they have those necessary skills and then so that they can also anticipate where the next frontier of digital twin research and innovation will be. So I know Professor Clinton started, so I don't know if Professor John wants to go first, or if you wanted to go first, open it up. Go ahead, Professor Clinton.
All right, thank you. I think let me just build on what Dr. Melissa just said now. In terms of BEAM, I think one of the critical skills when it comes to digital twin is the expertise in BEAM. In BEAM 3D visualization, and also even skills in systems engineering is really essential for creating accurate digital virtual replicas. So I believe that in developing digital twin systems, we kind of really require a multidisciplinary blend of technical, analytical, and even at the same time, domain-specific skills. So I think our students, even though we don't really, within the built environment, there is no core computer modules that actually teach them about software development. But I think some of the key competencies we include things like data engineering, because if you look at the Unreal Engine, you need a particular data engineering skills, software development understanding, and even IoT integration skills. So the other aspect is we also need to even kind of really bring in, probably within modules in the built environment, things like simulation modeling, which is not very really common unless in some modules like energy simulation and all that. But the other aspect is the machine learning ability for predictive analysis. So you realize that in terms of partnership, I think universities really need to collaborate with technology providers. We still struggle with some of those things within the continent. In Africa, in South Africa, there's a disconnect between universities and industry collaboration. But what we are trying to do at the moment, there are some representative of Autodesk who are in the country that we're trying to collaborate with in terms of between our university, the technology provider, and also some engineering firms. And the other thing that we kind of also struggle with at the moment is developing our own local sensors. We kind of really struggle getting local sensor manufacturers that will actually help with the IoT devices in terms of actually carrying out some of these measurements. So I think collaboration between either universities, technology providers, and the other aspect which is helping us at the moment is the collaboration, support from government rather, because the digital lab that we're developing at the moment is actually sponsored by the South African National Research Foundation to actually create that particular uh, digital lab to carry out some of these particular experiments. Like one of the equipment we are buying is over $100,000. So university will never provide that kind of funds for you to invest in research, but we're getting those support from government agencies and others. So I think it's going to be a combination of skill sets, partnership that we actually ensure that we are kind of really able to sustain digital twin ecosystems. Yeah, thank you.
Thank you. Dr. John or
Yeah, thank you. So at the University of Lagos, our students in the built environment are being introduced into the building information model, the BIM, and they currently learn the various levels and how to deal. We have the NEAT Hub. It's an initiative of government called NEAT-DA. It's an agency of the federal government, and we have a hub in the University of Lagos where students can pay to learn machine learning, artificial intelligence, and all of that. But currently, the faculty has written a proposal for the donation of a digital lab, because being able to drive this level of technology requires having a digital infrastructure lab to where students can learn and practice and have this knowledge shared. Now, Autodesk has partnership with the University of Lagos, and they come in annually to train our students on the use of Revit, ArchiCAD, and all their software. So we have that access currently. In driving digital technology, digital twin, artificial intelligence, BIM, there's truly, like Professor Clinton said, a need for collaboration between industry, the academia, and other institutions and agencies of government, because you cannot take over, for instance, the research on digital twin in handling air quality in Lagos State. You need partnerships with agencies of Lagos State on environment, and they are open to this partnership. So it's not something that can be done single-handedly by research. It really has to bring together a collaboration of the town and the gown. Thank you.
like to add to that?
Yeah, I would say, I would echo, what Dr. John and what Dr. Clinton said, like the So it's building information modeling, but it's understanding how to do architectural modeling. I think that that's like a skill that a lot of engineering students in particular have lost. So I think it's, you know, both of those things. And I think on the data science part, that's also really important to integrate data science within engineering and beyond. I would say I think there's a unique opportunity for what we call like owner operators in the US to be leaders in this space, especially related to universities or governments, because they have a stake in the need and want to integrate infrastructure systems. So for example, universities often operate their own at like little energy plants, right? So they have a desire to reduce energy. They might have complaints from faculty, staff, and students related to indoor air quality or, you know, related to the energy use. So there's a direct kind of relationship that I think owner operators really we should collaborate with them, especially in the beginning of the development of these different technologies. And so I would emphasize that collaboration. And I'll stop there.
Thank you, Melissa. So I have more questions, but in the interest of time and also to give our audiences a chance, I'll open it up for questions from the audiences here in the room, as well as those who are on Zoom. So for those who are on Zoom, you can, as Tina already mentioned in her message, you can either unmute yourself, raise your hand, unmute yourself, or type your question in the chat. Questions from audiences here in the room while we wait for.
So, as you know, I never have questions, but I'll come up with 1 or 10. One of the questions in the digital twin that we have faced is how to do the modeling in a cheap and accurate way, right? So, and so I was interested in the first and last docs that talked a little bit about the integration between the digital twin and the physical plant, and how you're doing this assessment that hopefully is automatic and not depends on people. That's my bias, right? So if you depend on people, it's going to be inaccurate and expensive, at least in the places where professionals cost $100 an hour. And so if you guys could, if you all would talk about it, that would be great.
So I can go first. So, and just in case people didn't hear, our friend asked how to do digital twins that are cheap and accurate. And so I would say we don't know yet, especially at like the building level or at kind of the broader infrastructure level. And I think that again shows where we're at in the development of the technology and the development of the field. But I think what I am seeing in most cases, people are creating digital shadows with maybe a little bit of data exchange at this point. And so I'm not, especially in the built environment. I think we don't know that yet. The original place where digital twins were born out of was in the manufacturing space. And so I think, and also at that scale, I think that might be a place for us to look first to better understand what that sector's been able to do.
Thanks, Melissa. Professor Clinton or Professor John, if you would like to add to that.
Yes, I think I would just want to add to that a little bit, like in our case, based on the research I had presented. I think in terms of creating a very cheap model, I think one of the things is that we kind of start from a very, should I call it a very small scale, where we kind of use a enormous smartphone camera that is built in with a LiDAR scanner. In fact, we actually use an iPad. Okay, but you realize that in terms of a large scale, you need a very good LiDAR scanner from Faro, which we're actually trying to acquire at the moment. So when you use like when we use the iPad with the LiDAR scanner, it kind of really helped us to generate a 3D model of that particular room without really using expensive equipment. So we realized that that particular digital copy, which we're trying to clean and then adjusted it, then fitting it into the Unreal Engine and all that. So you realize that the issue of data quality when you don't have the right equipment can actually be a problem. But with what Melissa had presented, you realize that using the BIM model or even using the Revit modeling and all that, that also helps a lot to actually be able to create not too expensive digital model. Thank you.
Thank you, Professor Clinton. We had a hand raised from the audiences. So, Kenny, I believe you have a question. So, please go ahead.
Hi, thank you very much, and I feel honored to be a part of this forum. Um, I am a Canadian-based financial analyst, so I am going to be chiming in my 2 cents from the financial perspective. So, first off, I think it's very commendable the perspective with which this whole discussion is coming from, and also the fact that we cannot overemphasize the importance of the financial implication of making adequate planning, the financial implication of ensuring that we leverage on data to build sustainable housing and other infrastructures. So I also want to just mention, if it's possible, to kind of collaborate with institutions, schools, and other organizations here up north in Canada, as we currently, the government is looking for collaborative ways to improve the housing and other infrastructure sector in Canada as a whole, based off of the we have a relatively larger population relative to the housing infrastructure available on ground. So I believe discussions like this would be very beneficial to institutions here in Canada. I'm not sure if we have any institutions here represented, but I feel if we can explore such collaborative opportunities, it would really add value to us here. Thank you.
Thank you. Very insightful.
I can add to that. And so first of all, thank you so much for representing Canada. I mean, that's a big responsibility. And the whole financial sector. So I would say maybe one of the things we could do is reach out to you afterwards to see if there's an opportunity for us to collaborate and learn more about your interest and really join in the conversation in North America.
Thank you. Definitely. Thank you, Kenny. Are there any other questions from those who are on Zoom? Don't be shy. Okay, any questions from those who are here in the room?
Okay, I'll ask the question, and I think we have another one here in this room too. So first, Prof. Clinton, Prof. Amy, Prof. Melissa, thank you all so much. This is all been very new to me, and so it's wonderful to hear the work that's happening. It lets me get back to my civil engineering and environmental engineering roots, which is always nice. I think this question is for all of you, but I know, Prof. Clinton, I've heard you speak quite a bit about potential intersections with public health, which is the school where my primary equipment is. But those potential intersections, especially as we talk about indoor air quality and just indoor environmental quality. And so I'm wondering how much data is being collected that really looks at like the use of the space, because I can imagine there's a lot of focus on the materials and kind of the building of the space. But we know that there's always going to be that intersection with the use and the people. And so even though it gets into the messiness of the people, not just the materials, I'm wondering, what type of data are being collected, or if that's a future space to explore.
Okay. Can I respond? Okay. I think when it comes to the aspect of digital twin for environmental quality, I think there is a substantial amount of data that is being continuously collected. It all depends on the kind of the kind of IoT device you are using, because some IoT devices have capability to measure a lot of parameter. Like the IoT devices that we have at the moment is able to measure the temperature within the space, within the room, even the humidity, like what I said, like the CO2, the carbon monoxide, the air speed. Also, we kind of also try to drill into even the particulate matters like 2.5 and 10, and also the light level. And then kind of relate that to the occupant related indicators in terms of how it actually enabled how they feel when they're in that particular space. So I think data is typically captured for, let's say, every minute, as long as that particular sensor, that IoT device, in the current, like the one we're using at the moment, looks like a Wi-Fi. It's able to actually, we don't use multiple IoT devices, just one IoT device that actually measures this particular all these particular parameters within a minute or within seconds. And then you realize that this kind of really results in thousands of data points per day for a single room. So we are not collecting data in terms of the properties of the wall, like the wall materials and all that. That we kind of really leave out. However, I realize that from one of the things that we were discussing the other day was like even the quality of the type of paint might also kind of really have an impact in terms of the reflection of the light, in terms of the light levels, and also looking at even the terms of the humidity. So, but these are some of the things I want to explore in other research that we're looking at. But you realize that when the sensors operate, because they're operating simultaneously, the system kind of really generates a rich data set that will enable us to kind of really accurately track indoor conditions, also help to detect early issues. That's why from what we kind of did in the last experiment, that's why we are trying to look at large classrooms like a lecture hall, where we're going to have lecture halls that can actually accommodate like 100 to 500 students to see if that the indoor environmental quality will also behave, makes the student to behave differently from this particular office space that we actually use. So the system kind of really helped to generate a lot of rich data sets so that we are actually able to effectively analyze for improving the environmental performance. So I think later on we'll go into the physical properties like the quality of the, let's say, the wall materials, even the tiling, or if it is wrong, to see if it actually contributes to the indoor environmental property behavior in that particular space. Yeah, thank you.
Yeah. Thank you so much, Professor Clinton. We'll take one last quick question. We have an audience here in the room, so please.
I don't have a question. There's been a number of data ontologies and schemas across like building automation system vendors, such as Beads, the Brick schema, Modelica, etc. Can you speak to the adoption of those standards and schemas within academia, as opposed to just what I'm seeing on the kind of vendor operational side?
So the only one I recognize is Modelica, so clearly we need to collaborate. Yeah. That's what I was.
Yeah.
Thank you.
Thank you so much. So we're almost and
His reaction. We should have taken that one last question.
This was so much fun.
Yes. So as we're almost out of time, and as we wrap up today's panel, I will extend my sincere thanks to our distinguished speakers, Professor Clinton, Professor John, and Professor Billick for sharing their expertise and research and insights. So very insightful. So your perspectives and research that you shared truly highlights, the potential of digital twin technologies and innovation. I also want to thank our audiences who are here in person, as well as those who are joined us virtually, for taking the time to join us today and for their participation. And of course, a special shout out to Tina for bringing together this group and making this event possible, as well as all other organizers. Gina, thank you so much, and Mary, Melissa, and so this was really good. And I thoroughly enjoyed it personally. And as Tina mentioned at the beginning, we'll continue this conversation. The third part of the series will continue in the spring term. So you'll get to hear more, and from other speakers as well as different perspectives. So thank you all, and have a wonderful rest of your day.
All right. Thank you very